Let's look at an example involving conditional expectations, the idea that we just spoke about. This one here deals with um, f of t. Okay, we are given f of t is 150t cubed plus t over 38 for values of t between 0 and 1. That's the density function you're given for the random variable t. And you're asked to find the expected value. Let me write it here. Expected value of t squared, given that t is bigger than 0.9. So remember, this involves the use of a formula. After a while, you'll get used to it, right? And there is a numerator which talks about an expectation, or a numerator which involves the formula that deals with expectations, keeping in mind the values the random variable can take. And there's a denominator, which is a probability. So let's work out the denominator first, the probability t bigger than 0.9, right? And that is not a hard thing to do. You're given the density function. So we'll work from 0.9 to 1. Okay, that's because the largest value of t is 1. And you have a density function. This is a simple integration to work. You can easily do that. Plug in the numbers carefully, use a calculator, and you'll get 0.3418. That's your denominator. Now we have to work out the numerator. So that'll be xfx, right? Remember this? But this is the generic formula for expectation, right? So of course here it'll be t f of t td. Again, t f of t dt. And we are going from 0.9 to 1. So this, let me backtrack, right? This is not expectation of t, right? Sorry, my mistake, right? Let me adjust. It's expectation of t squared. So this should be t squared. Okay. So let me say that again, yeah? The denominator is easy from probability, right? The numerator, be careful, right? It is the expected value of t squared. For a moment, I thought it was t. That's why I said t here. Okay. The expected value of t squared, given that t is bigger than 0.9. So this would be like, remember, expected value of g of x is, remember g of x? The expected value will be just g of x fx dx, right? Same idea. Now it's t squared. Be careful, the limits go from 0.9 to 1 because that's the condition. So clear this up a little bit. Okay, this integral, work it out, you'll get a number, and then take this number here and divide by the number you had earlier from the probability, and you'll get 0.9083. Good. Now let's move on. We have an actuarial exam question. So let's deal with that. Let's read the question slowly. Yeah? We have the random variable. X has a CDF. X less than 1 is 0. Between 1 and 2, yeah? 1 is inclusive. X squared is a quadratic, right? X squared minus 2x plus 2 divided by 2. And for values of x bigger than or equal to 2, it's 1. Okay? You're given the CDF. I changed the question slightly, right? The original question asked for the variance. Let's just go ahead and find the expected value of x squared, and finding the variance is easy, right? You have the expected value of x squared, you can easily find the expected value of x, and then, use the variance formula and we're done. So let's just do this and move on from here, okay? So very quickly, a quick check. If you work out the value of the distribution function at x equals to 1, okay, at x equals to 1, just plug it in here, okay? 1 minus 2 is a minus 1 plus 2 is 1, and 1 divided by 2 is a half, okay? You can work that out. So we are told that x less than 1 is 0, right? So I've given you a little sketch here, right? So less than 1 is 0. And then when x equals to 1, there is a jump, right? There's a jump at x equals to 1, because that would mean to you that the probability x equals to 1 is a half. Okay, again, there's a jump at x equals to 1, which indicates to you that the probability x equals to 1 equals to half. Okay, so please be a bit careful about this. The quadratic itself is easy, right? That's no big deal. Now, so let's set up the density function, right? Let's set up the density function for x. Let's set that up. And then the calculation for the expected value of x squared will be quite easy to do, okay? Okay, so the density function of x, here we go, will be equals to a half when x equals to 1. We just worked it, right? I showed you there's a jump at x equals to 1. And this part here, right, for values of x between 1 and 2, x minus 1, how do you get this? Just differentiate this, right? Just differentiate x squared minus 2x plus 2, right? X squared minus 2x plus 2 over 2. When you take the derivative, you'll get your answer, right? And this will be x minus 1. Okay, you differentiate your CDF, you'll get your PDF. So that's what is given here. So now you have your density function. You can easily work out the expected value of x squared. Take care of this first. 1 squared times a half. There you go. And then we can take care of the continuous part here. X value is going from 1 to 2. Remember, this is gx, right? It's x minus 1, so don't forget. So it's x minus 1 times, okay, times what? This one here, x squared, right? Let me remind you of that again. The expected value of g of x will be equals to the integral g of x, f of x dx, right? So f of x, we know is x minus 1. There you go. And what is g of x here? It is x squared. So that's what you see here. Do the integration carefully. Don't forget this, yeah, it's very important. Clean that up, use a calculator, and you will get your answer 23/12. Okay, we have another example here which involves the coefficient of variation. Let me do that very quickly. Okay. You're given the expected value of x is 4. The variance of x is 16. Okay, that's good. You're asked to find the coefficient of variation of this function, right? So when you want to find the coefficient of variation, you need your standard deviation. You need your standard deviation, and you also need your mean. So the formula for your coefficient of variation is this thing here, right? So be careful, right? We are looking for the coefficient of variation of this function here, okay, g of x. So the variance of, it's written here, so let me just follow the solution. The variance of this is what? Good. Remember the formula, a squared variance of x. So 1.2 squared, 1.44 variance of x times 16. Okay, 1.44 times 16, you will get this. The mean, hey, that's easy, yeah? Okay, the mean is easy because the mean of 1.2x plus 100, this will be minus 1.2, the expected value of x plus 100, okay? So we found the variance of this so that we can write the standard deviation, because standard deviation is just the square root, right? Then I had to find the expected value of this, okay? And I've done it here for you. Expected value of x is given 4, so minus 1.2 times 4 plus 100. You'll work out the value. This is in your denominator. This is your numerator. Don't forget the square root, yeah? Use a calculator and you'll get 0.0504.